All right, I think we're ready. All right, we're gonna do some resin printing today. Well, I don't know if we'll actually do resin printing. We're gonna talk about resin printing. There's some resin printers over here that we'll look at, and maybe we'll start a print. I'm not sure. Did get the little dual color guy, and it actually the greenish gold and that blue kind of look all right together. And all I did was what you saw at the end of the last video, where that Z height, I sent it back to minus, or I had raised it up, and then to Z of -10, so it raised up, and then I did Z10, which dropped it back down instead of Z whatever I had before, 5 I think, and it worked fine. There's one little issue I'd probably want to keep working on, and that is that when it starts printing the new color, there's a little bit of time before it actually begins to extrude the filament. So I think there's maybe a little bit extra purge that's needed, or something, because it just didn't quite start printing immediately. There's a balance there, right? If you have too much coming out, then it's going to kind of drool everywhere. So tuning that would probably be better. But it did work. It worked a lot better to use, I think it's actually on this page we're looking at, to use this code where we can control all the little pieces here, versus using the M600. There's the Z -10 to raise. So these are typically in terms of the bed, even though the bed doesn't move up and down on our printer, on the Ender 3. That's what the code is written as, like the bed is moving up and down, versus the nozzle moving. So if you actually just copy this code exactly, it'll work. There might need to be a little bit more extrusion here, purge, to get it started right when it goes to print the new color. But other than that, it worked fine once I put this the way I had it written the first time. So there's one little thing on this particular, well, not on that printer, but the one we were using, these messages don't show up, so you do have to kind of know what's going to happen. They would show up on a regular Ender 3, though, on that LCD screen. And on that other one, they would show up if I put the LCD screen in Marlin mode. So it's basically emulating the regular screen that the Ender 3 has. But on that touchscreen, they don't show up in the touchscreen mode. But this will work as you just find the layer that you want to insert the filament, copy this and paste it into that spot, and like we did yesterday, and you can get some dual color prints. There they are, and they're pretty easy to do, and they can add a little bit of something. I mean, you can always paint the top of something if you wanted to, but it's kind of cool when it's a separate filament like that. All right, what we're going to do today, though, is talk about this resin printing. So let's get this out of the way. So I've got two things here. I've got the actual printer. This is the Anycubic Photon Mono X. So it's about, this would have been new last summer. So the current printers of this style are, they're still in the same size, maybe a little smaller and a little bigger, but this is kind of the medium size, I suppose. There's certainly bigger ones, and there are some smaller ones. The thing that has changed this past year from last summer to this summer is the screen. So the way these work, let's see, they're really messy, but I'll get it open so that we can kind of look inside there. Also, this resin in here, the blue stuff, that's resin. So that's a liquid, uncured. Actually, it's probably curing a little bit as we're in here. It cures with UV light, so you don't want to leave it out too long, because it will cure in the vat there if we wanted it to. Whether we wanted it to or not. But the way that they cure is through UV exposure. So let's get this out of here so we can look at what's under it. All right. Right here. Maybe like that. So this screen is actually a basically LCD screen. I'm noticing a little bit of resin that's around the edge. I want to clean up there. That's what I'm saying about these things being messy. They can be quite the mess. So what this will do, this is the Photon Mono. So this is a mono screen, black and white screen. That is actually the better screen for these type of printers versus a color screen. What that screen is doing is it's not emanating the UV light. What it's doing is it's actually acting like a mask. So it is occluding certain areas and there is a UV array down in the base down here. I can't get to it without taking the printer apart. But down inside there's a UV array of lights that's shining up. And this screen will block some of that in a pattern, whatever your printer needs at the time, and allow other pieces of that UV light to shine through. And when it does that, then the bottom layer in this vat, I'm going to put the vat back so I can kind of make sure nothing drips on the screen or anything like that. Let's get it bolted back down. So this little platform will lower down into the vat, and you build your part kind of from the bottom up. This platform raises in your layer height as the prints are happening. So maybe we can get a print started so you can kind of see that they're slow in one way, but they're fast in another way. So the way they're slow is that each layer, once you're into the printing, the first couple 4 layers take like 20 seconds a piece to cure on this printer. But after that, each layer takes 1 to 2 seconds on a monochrome printer like this one. But the layers are super thin. Like they can be 50 microns or smaller than that. Like the rough layer is 50 microns or whatever. So they can be super thin layers. So that can take a long time to build up anything that's tall. The way they're fast, though, is that the entire build area here, the whole thing, can be exposed at one time. So you could load this entire tray with one giant model or a whole bunch of little models, and it wouldn't take any longer to print than one thing on there of the same height, because the print time is really controlled by the height, not the area here. You can expose the entire area all at one time. So the way they're fast is that it takes 2 hours. Let's say it takes 2 hours to print something that tall. It takes 2 hours to print 10 of those things that tall, if you can spread them out on the little build platform area. We'll look at the slicer in a minute. So in the sense that just the sheer amount of material you can print is pretty fast, but each layer is going to be kind of slow because there are really thin layers. So you get an economy of scale in this one where you don't get that in FDM printing. If you have one model that takes 2 hours and you want to print 2 of them, even on the same build platform, it's going to take 4 hours, because if one takes 2, then another one is going to take another 2, because it physically has to go over there and draw the lines for the second one. The only way you speed that up is by a second printer. So here you can actually get some economy of scale on your parts, and per model print time is actually faster, assuming they're all the same size models or whatever, than it is on an FDM printer. This one I've got a couple of accessories with that I think are kind of important. This little guy back here is a rechargeable air filter. Maybe we'll go ahead and turn that on. So it just kind of sits back in the back corner over there, and it's a little carbon filter, because these things are a little bit smelly. This particular resin is not so bad, but some of them are quite strong. The resin comes in a little brown bottle, brown soap, because they do cure in UV light. So you have to keep them stored away. This one's I haven't opened before. This is Z-Mud. You usually get 500 milliliters, maybe 1,000 milliliters at a time, and that will print quite a bit. It doesn't. You can treat these kind of like you do in FDM, where you have hollow insides. Usually with this, you have completely hollow insides if you want a non-solid block of plastic when you're done. And your slicer has ways to basically create a thin wall structure and then drain out all of the resin that didn't cure on the inside. Or you can just print solid stuff, but it's going to be heavier, which may be beneficial, but it's also going to, use more of your resin. Let's see what else about them before I close it back up. Oh, the other thing I've got, you almost have to have some gloves here. I'm going to put these on. This resin, it's one of those materials where continued exposure to it, like getting it on your skin, is actually worse. You don't get used to it and kind of immune to it. As you get more and more of it on you, the reactions get worse and worse. So you get chemical burns if you get this resin on you too much. What I wanted to show here is most of these printers don't come with this, but it's a pretty handy little addition, and that is, let's see if I can get it off of there without splashing everywhere. Wow, it's really got a hold of it. I don't have a good way to get under there. Let's see. You gotta see it gets all over you, because the bottom here goes down in the vat, and you're gonna get stuff all over everywhere. And there we go. Just couldn't get the edge of it. So they do have flexible build plates. See, it's dripping. You don't want to drip it on the printer. I'm actually letting it, I'll show you in a second here. You can kind of see that orange mat down there. That's a silicone mat. So stuff doesn't really stick to silicone. And what you can do is, I'm going to go ahead and get rid of these. Got a little trash bag over here. Get in there. So if they land on the silicone mat, it's not a big deal. You just let it cure there and pop it off at the once it's cured. I did get a little bit right there, though. I don't want that on the printer. So that flexible build plate will help you remove parts just like it does in an FDM printer. So those are usually not, currently, they're not standard on most of these printers. I'm going to go ahead and put this guy on. Okay, there we go. Hopefully I'll remember to turn off the little air filter back there. But you can kind of see it just landed. Got two little drops right there. You can take, hold on. You can take a little UV flashlight and, cure them instantly, or you can just, if you're matte, this is a Wham Bam, I think it's called a slap mat is what they sell it as, but it's just any silicone mat. At school, I just use a dog food mat, so one that you would have under your dog's water bowl or whatever. It's actually cheaper, and it's still, all it is a silicone mat, so that you can peel off cured resin. I'm not really sure how long it's going to take to cure this, but let's see if it's cured. Yeah, see? So you can just cure it with a UV light and then peel it off of there or throw it away or whatever. When it's not cured is when it is, see, that one's still not quite cured. When it's not cured is when it is caustic to you. Once it's cured, then it comes in, it's a solid piece of resin. You can do whatever with it. So I'll turn that off, except I can't get it to push the button. There we go. This other machine over here, this one, I think is essential for resin printing. It is not actually essential for resin printing. I just think it is. Because when I started resin printing, first of all, the machines were a lot smaller. This one, I guess I didn't tell you, this one can print about 8 inches by, that's probably 5 inches by about 10 inches. So it can print some big parts. The first ones were more like 3 by 4 by 5 or something, much smaller volumes, which are still fine for most things you're going to resin print. Anyway, the process is once this printer is done, the parts are hanging underneath here on this little build platform. That little knob up there lets you remove the build platform so you can actually get to them and move them around and scrape them off of there or whatever. The flexible build plate does make that removing part a whole lot easier because they can get really embedded onto the build surface here, and you end up, scraping them off of there. So they end up hanging there, and they are coated with uncured resin because they've been down in that vat, and they themselves are partially cured. So they're cured enough to hold together, but they're not like the final hardness of how hard they're going to be when they're finished curing. So this machine makes the next step a whole lot easier. So you get your prints done over here. Then you could either just take this entire tray and drop it in here, or you can scrape them off and put them in here. But this is it's a two-part machine. So inside that little bucket inside there is isopropyl alcohol. You can use some of these resins they clean with just water. There are some water curable, cleanable, rinsable resins. Most of the ones that I use they clean up better in some kind of alcohol. So I use IPA. And so this vat is filled to, I don't know, it's got that much or so IPA in the bottom of it. And you put your still yucky parts in there, and it will swirl around for a while. It's got a timer down here, and this button basically is, are you washing or are you curing? And so it will wash the parts and get them a little bit clean. Then I usually drop them into a water-filled, you can either rinse them with water, or I have a little ultrasonic cleaner for like jewelry, and I put them in there. And it's just got water in it to get any of the IPA off. If you don't get the IPA off of there, they'll get kind of cloudy. Your model will get kind of cloudy. The IPA, the way it dries, will cloud the model. So you're basically cleaning the IPA off at that point. And then this same machine will do a curing. So it has a turntable at the bottom, and got a little mirror. In the back of it, there's you can kind of see that column right there. It is full of UV lights, LED UVs, and it will shine in there and cure your model. And that's when you end up with this kind of thing. So let's see if we can get some of the detail close up, because that's the reason you're doing resin printing usually, is that you are trying to get a lot of high detail. So let's see, it's very blurry. Let's see if we can unblur. That's pretty good. So this is some little model not off of Thingiverse. Thingiverse doesn't have as many models that are like made for resin printing. That one came from My Mini Factory, I believe is where it came from. Or maybe a Patreon somewhere, it's where it came from. I don't remember. Anyway, that's the kind of detail that you might be able to get on a low quality resin print. So this isn't the high, really small layers. This is kind of the low quality for the layers. So the resin printing low quality layers are still smaller layers than FDM fine quality. Here's one that I painted up a while back. So this is a resin print that also, I don't remember where it came from, probably a Patreon somewhere, whatever. But that's the kind of thing that you can get from resin printing, is these really, sharp details here. It's really tiny. And this one is, I think, like 2 years old. So that is a color screen resin printer, not a mono screen. So it's a little slower. And it's probably not printed at a very high resolution either. I typically don't bother to print at the super high resolutions, the really thin layers, just because there's not much need to in most cases. Now, this printer, the one that we're looking at or looking off of the side at, it's a, I believe it's regular HD screen. Maybe it's a 4K screen. It might be a 4K screen. I don't remember. I have to look it up. But the current ones are 8K and 6K screens. So they're like double the number of pixels here, which makes them smaller. Either that or you can make much larger printers with the same XY resolution. Usually what you're doing with one of these resin printers is you want some super fine, high detail prints. Maybe the material itself is the important part. Like you need a more solid part versus what FDM is going to do for you. So it might be that the material is the reason you're printing on resin. But usually the reason you're printing on resin, on this kind of resin, this is called masked SLA. So mask meaning that it's the screen is really creating a mask for the UV light to shine through. SLA is Stereolithography Apparatus. Actually, the first printer I ever saw was a SLA, so Stereolithography Apparatus, and that was back in 1995, and it was at a orthopedic company, and those printers, they still exist today, and they still are kind of the top of the line on what quality you can get. They use a slightly different idea. So these printers, the resin cures at 405 nanometers, somewhere in that range. Let's see if it says on here. It might say, but it's covered up with a sticker, I think. I'm pretty sure it's 405 nanometers of UV light. The SLA printers, they actually use a laser to go in and cure the resin. So they have a little bit broader range of materials that they can use. Although every day there are flexible materials you can use with this resin printer. Transparent materials are not like perfectly clear. Clear gets to be a problem because most things that are perfectly clear resin wise get amber colored with UV light. Over time they turn kind of yellow, so they end up kind of cloudy. But there are flexibles, there are transparent, there are plain resins like this one. There's these that are kind of general purpose resins. So there's a wide variety of resins, even for these masked SLA printers. The difference is this even this one, this Mono X. Let's see. I don't want to lie here or lead you astray. Photon Mono X. $380 on sale today. So right there, that's pretty cheap for what you're getting. As far as now, here's the 6K version. That's not what I am showing off here. I'm showing off the 4K version. Wi-Fi control. I don't know if you noticed, but in the back of the printer there's a little antenna, so you can talk to it remotely. You don't have to do the SD card. That's how I normally do it, is a little SD card or thumb drives. But it does have Wi-Fi that you can send files to it that way. But $380, that is not bad at all for what you're getting with this, assuming you want to print high detail models. They don't have to be tiny either. 192 millimeters by 120. That is smaller than the print bed on the Ender 3, but it's not that much smaller. It's a third. It's probably about a third of the size total of Ender 3 that you could print. And they make much larger ones. Like I said, this is kind of the medium size. There are much larger ones. Here's a small one, this little Sonic Mini 269. If you just wanted to get started, it's got a 5.5-inch monochrome screen. I would say if you want to do resin printing, go ahead and get one of the monochrome screen printers. They're over twice as fast printing time as the non-monochrome printers. Most everything that comes out today is a monochrome printer versus the color screens. It sounds like that's the opposite. Normally you want color, not black and white, but in this case, since you're using the screen as just a mask, the monochrome is superior. Do recognize though that screen is a consumable. So over time, that screen will you're burning UV light through the thing, and it's having to mask off that. So over time, it will eventually wear out. And so don't think that these printers are going to last indefinitely. They will wear out. The screen here is sort of like nozzles on the FDM printer. They last a long time, but and usually it'll tell you kind of what to expect. Let's see if it says in the description here. 2,000 hours. So that's a lot of printing time, but still it is a limited life, and they're not horrible to replace. Probably by the time you burn through 2,000 hours of printing, you would just get a new printer. At the prices that they are these days, you would probably just get a new one. The 6K, and then there are currently, I don't know if you can buy them right now, but there are 8K printers out there too. Different companies. Elegoo is a good company. I like the Anycubic Photon. They're a good printer. This is a big giant one here, 13.5-inch screen. So now you're basically getting close to the same size as the Ender 3. It's not as deep, but it's in the same range. Of course, it's a much more expensive printer. So they are reasonable for a consumer. The SLA printers, the ones that use the laser to cure, the cheapest of those that you're going to get is a Formlabs printer. Let's see if we can find. There they are. Well, you saw some of the prices over there. Let's go back. $2,400. Now these are kind of small they're in the same price size range of what we're looking at here on my desk. The material for them, the resin, is a little bit more expensive. It's a little proprietary. Can't just go to Amazon necessarily and buy whatever off-brand. But this is a bigger one here. But they're going to cost a good bit more. And these are the cheap SLA printers. A industrial SLA printer, it's a $100,000 machine is the cheap version of that. So, and they go up from there. So, if you want the laser cured and you get a little bit wider range of materials, then your entry level point on that kind of thing is the Formlabs printer. And it is a good machine. They've been around for 6 years or so, maybe somewhere a little longer than that, even somewhere in that time frame. 6 to 10 years they've been around. They were the first consumer level resin printer at all. Before the masked ones even existed, they were out there making little lasers that bounce around on mirrors. If you've seen the guy, I can't remember, on YouTube, the guy that makes the basketball that can't miss and things like that. He was one of the original engineers that worked on these printers. So they're a good company. They're a little bit more expensive. The consumables are more expensive, and unless you really need the engineering materials that they have, there's not too much reason to go to that level. I will say there's one other reason. When you cure with the laser, you typically have a little bit better, not resolution, a little bit better accuracy on your parts. So your parts, if you told it to be a certain size, there's going to be a little bit better chance that it actually is that size on one of the laser-based printers versus one of the masked SLA printers like we have here. The accuracy of the part size on the MSLA is not as good. It's not even necessarily as good as FDM printers. You really have to do some tuning and checking your machine on how it's going to do as far as accuracy of the size goes. Now, in this kind of stuff over here, it hardly matters if this guy is 2% larger or smaller or skewed in some direction. It doesn't really matter. But if that's a part that has to go in another assembly, then it starts to matter. And you will get a little bit better accuracy on these printers. Let's see. What else should we talk about on these printers? We talk about the slicer. We talked about the wash and cure station. Oh, let me just point this out. I mean, this is good detail and everything, but you can get similar. This little guy, I brought him over. This little guy is FDM printed. So It's not that you can't do similar things on FDM. Obviously, this one does not have the like super fine little details that this one has, but you can do pretty good with FDM printing also. The FDM printer nozzle that you start with is a 0.4 millimeter nozzle. They make nozzles all the way down to 0.1 millimeters. I would not recommend doing that anytime soon because it's very, very finicky, and you've got to have everything dialed in really well. Your E-steps, your flow rate, everything has to be really well tuned in order to effectively use the 0.1 millimeter nozzles. But this guy was printed with a 0.4 millimeter nozzle. It's just in the slicer. How did you set it up? You know, you slow down a little bit. I turned every layer in him into a top layer. So it basically took its time to create every layer, and it's basically solid. He's kind of heavy for a FDM print. So you can get the similar quality. Now it takes forever. This guy probably took 3 or 4 hours to print one of him. So it does take a lot longer on FDM. This guy probably, I don't know, he probably took 3 hours to print, but I could have printed, I don't know, I could probably print 15 or so of them on that board at the same time, and they'd only take 3 or 4 hours to print. So you do get the economy of scale on the resin printer, and you get obviously better detail, but it's not that you can't do detail and finer-ish stuff on an FDM printer. All right, let's move on from him. Let's look at the slicer a little bit. So I've got some parts. These got some little dwarves hammer guys back here. These little parts are for that horse that I showed you earlier. So this is, you've got your kind of same deal where you've got the outline. This is the lychee slicer. There are 3 big slicers for resin printer. There's lychee, there's Chitubox, and then Prusa. Prusa has resin printers also that are actually pretty good. The problem, I haven't used one personally, so I don't know, but my anticipated problem with them is that they're in the price range of those Formlabs, and so why wouldn't I just get one of those? So I don't know. But they're in that same price range. They're not as expensive, and you do have more choices on the resins and everything. But they're getting to the point where I would almost just as soon get the Formlabs printer, pay a little bit more and get that. But Prusa does make good resin printers. I've just never personally used one. So their slicer will do resin slicing. So the thing you have to remember, though, is that this is really going to print, I can't even rotate it that way. This is going to print upside down, right? So this is the surface that is, let's see, my mouse is, that's this plate up here. That's this guy. So this little thing. So it's all going to be hanging upside down from here. And you have to kind of think about that. Typically, the conventional wisdom, and this is not true in all cases, but if you're printing little detail things like this, typically you tilt them back. All of these little scaffolding, that's the support material that it uses. One thing that can happen that you don't want to happen with resin printing is if you try printing a really large flat, like if I printed this entire plate just flat with resin, then it may, or well, it probably will. There's a 80% chance that it will have this problem. It will try to stick not to the build surface, but to the bottom of the resin vat. On the bottom of the resin vat, there's a transparent, UV light has to shine through it, film that's similar to Teflon. It's in the Teflon family, but it's a FEP. And you will get your part stuck to it instead of stuck to the build platform. So you do have to minimize, or at least do what you can to minimize the surface area that's going to be on that build platform, because that's, or not on the build, that is on the FEP, because it has to peel away from that. So there's the way the process works is you slice your part. The little platform lowers down into the vat, like it's submerged in there, and the UV light comes on and your first layer is exposed for 20 seconds or so. This platform has to peel up, so it raises up, and all your stuff needs to stay stuck to this platform and not down here. So it's going to raise up a little bit, then it'll drop back down. It's going to peel it away, drop back down, expose the next layer, and keep doing that over and over again. So if any of those layers, when they go to peel up, if they stick down to the FEP, then that's going to obviously fail your print. The problem with most of these printers that I have is that you don't know if your part has succeeded until this platform is, up above the rim of the vat that holds the resin. You can pause and lift it out to inspect it to see if it's stuck on there or not, because you don't want to start some 6-hour print, walk away from it, and then come back 6 hours later and nothing actually printed. It's all just stuck on the bottom of your vat. That happens plenty of times. So you do want to make sure that it's kind of like watching the first layers of your FDM print to make sure it's going to look like everything's stuck down to the print surface. You want that same thing to happen over here. You just want them to stick to this build platform. So you do want to make sure about that. So back over to the slicer. The models, they don't always come pre-supported, with all these little supports underneath them. A lot of them that you get these days that are this style, where it's some little figure or whatever, they do come pre-supported. But if it's something you made, then it does not have pre-supports built into it. This reminds me of something. Look at what you're able to do. You actually have texture on this little cape here, and that'll resolve if you print at a thin enough resolution on your layer height. It can actually resolve that texture. It's kind of crazy what they can do when you go for the high resolution options on here, the type of things. It is not uncommon for to print something and some parts fail and other parts succeed. There is a tuning setup kind of thing, just like there is with FDM printing, where you got to get your flow rates and everything. Over here, you've got to get your exposure rates set up right. So there are some tuning prints that help you figure out how long do I need to turn the UV light on for each layer for it to not overexpose. If I expose the light too long, then it'll cure where I wanted it to, but it'll bleed out and everything will be kind of fuzzy compared to what you want it to be. If I underexpose it, then that layer won't get cured and it won't stick to the build platform and it'll fail the part. So there are some tunings that you need to do, particularly related to exposure time. So typically for this kind of printer, the monochrome printer, you print the first 4 layers. Those are your burn-in layers that you really want them to stick to the build platform. So the little upper platform on the printer. You really want those sticks. So they're going to be burned in. Well, let's see if it'll tell me what my burn-in time is. 20 to 30 seconds probably. Let's see if... Oh no, that's actually parts. I'm just going through here. I don't use this one very much, so I have to remember what I'm doing. All right, so here are some of my my printer, Photon Mono X, resin, Anycubic Rapid Aqua Blue. Each resin does have a profile built into it, kind of like in Cura, where you can change material, PLA, ABS, TPU, all those kind of things. There's these starter profiles, and so you can find some of the existing profiles, and it will have what it thinks the right exposure times are for each of those. So you pick that. Anti-aliasing off. So I don't have the pro version of this software, so I can't do the blur anti-aliasing. So anti-aliasing talks about the pixels in the screen itself. You can do anti-aliasing, so I don't know if it's very visible here. You can kind of tell the difference. The blur one is extreme here. So the edges here are pixelated, so they, they're steps, because the pixels are these little rectangles that are on the screen. They're physically there, they're just really tiny. When we look at them, typically they don't look like rectangles, but if you zoom in really close, that's what they are. And so by default, the anti-aliasing is off. And then you've got a standard anti-aliasing, which tries to kind of blur the edges a little bit so that you don't get the stair-step effect at that tiny little scale. And then there's these, more extreme blurs. I usually leave it off because there are 4,000 pixels on this little screen, and that's usually small enough to not notice. But some people want the curved surfaces to be very curved and not have that stair-step effect. And so you do that. This part's going to take 2 hours and 45 minutes to print these. It would take that same 3 hours if I loaded up, just kept putting in. Well, let's do it. Let's just. Oh, I may have to go back to layout. So let's just copy a bunch of these guys. Where do I copy? There he is. Let's just make, I don't know, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11 of these would fit on there. Let's do 10. Not sure why it takes so long to copy the same exact thing, but it does. Oh, last night, I even found one of these slicers for the iPad. So I have an iPad. It's not a free one. It is a paid, I think it was $3 or $4 per month type thing to use it. I have not used it, so I can't comment on if it's any good or not, but that was surprising to me. There are some modeling packages on iPad, and so maybe that's what they're thinking, is that you can do some modeling directly on your iPad, slice on your iPad, and then wirelessly send your file over to your printer. So now I've got a whole bunch of these, and I still have more room. So apparently I could fit maybe another 10 on there. So I could fit a whole army of little dwarfs. They don't have to be the same. I just copied the same guy over and over again, but we could have copied any number of things in here. And let's see. Let's go to export. It's the same time, 2 hours and 45 minutes and 7 seconds, because it's all based on what's the tallest point it has to get to. So that's where you get, I can suddenly make, how many are on here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I can make 13 of these in 3 hours. So let's see what that is. And then there's that other little skeleton guy. 3 hours is, oh, come on, calculators being crazy. And I can make 13. I could easily put another row there. And I think I could get another 3 rows. So we could get 4 by 1, 2, 3, 4, 5, 6, 7. We could print 28 of these little guys, I think, in 180 minutes. That's down to 6.5 minutes per model. So that's where you can get economy. That's assuming they all succeed. You might probably have a couple of failures in there. But once you're tuned in, you probably wouldn't. Once you get your exposure rates right and everything, you probably wouldn't have any failures. So you could see where the economy of scale actually does occur in resin printing. You think about trying to print one of these little guys on an FDM print, and if you're trying to get this detail or any level of detail, it's gonna be 2 hours, and then you want to print 30 of them. So now you're 60 hours in, where you're 3 hours in to do that on resin printing. So, and you get better detail. Let's see. So I could export it to actually print the thing. I wanted to see the resin details, though. Maybe I have to click on it. Let's see. Edit. There we go. So, all right. Apparently, I'm doing 6 burn-in layers. Normally, I do 4, though. This might be the default settings. Normally, I do 4. You don't want too many burn-in layers. The burn-in layers are gonna be a little bit larger. In this case, it doesn't matter because nothing important is actually touching the build plate. So it's really only these little kind of stands underneath all the supports. If you had your model, the actual model, sitting directly on the build plate, which is fine for some things, those first few layers are going to get the same kind of thing, elephant's foot, that they do on FDM printing, because you're going to overexpose them and they're going to be a little bit bigger. Now the good thing is resin is really easy to shape and sand. The bad thing is you have to wear a respirator and you have to be conscious of the resin dust, because it is something you don't want to breathe. All right, let's go back over here. So I've got 6 at 20 seconds. So again, that's on the mono screen type of thing. The color screens, that's going to be a little bit longer. I've got some speeds on, it even calls it retract speed. It's not actually retracting filament, obviously. There's my layer thickness. And let's see if it shows. Oh, it just says 50 is actually really thick. So 50 microns is a really thick layer for resin printing. If you can easily go down to 30, even 20 microns, and get some really fine detail. It's obviously going to take longer because that's multiplying the number of layers you have to print. And it's going to be more susceptible to overexposure if you don't have your exposure times really dialed in. Here, the regular layers are 1.5 seconds. On a color screen MSLA printer, that's more like 4 or 5 seconds, so they are much slower than the mono screen printers. Lift distance, you know, how far to lift off the bed every time it has to peel away from the FEP sheet. You can, they do have these scale compensations. If you know your printer always is deformed in some particular dimension, you can work for it here to adjust that. You can even calculate the the price. These little resin bottles are not terribly expensive. Let's look at a resin, not epoxy 3D printer. Well, I don't want the printer, I want the actual resin. $45. This is a kind of a, it's called tough resin. I've used it before. It is a more durable resin. So the one thing about like this one, you can even feel it and tell that it's pretty brittle. You know, I'm not going to have a whole lot of flex on this thing before it would just snap. But they do make a little bit more expensive resins. This is for probably 500 milliliters. Can't tell. Well, it says a kilogram on there, which, yeah, I mean, it's not water, so I don't know that that's, normally they measure in milliliters, not grams, but that one, for whatever reason, measures in grams. So you've got, 30, here's a $25 one. There is the 405 nanometers I was talking about. That is one thing, when you buy your printers, a resin printer like this that uses the Masked SLA is going to pretty much cure at 405 nanometers. So you don't want to get one of the ones that's made for laser curing. So you can see, in the same price range, they make some cheaper ones. That's just the standard regular old stuff. They make some translucent ones that are really cool. Let's see if I can find a translucent one. The translucent ones actually look cool, and they're a little bit better because the UV light can get inside of it to cure the inside part. So there's a smoke colored one. Do not expect it to look clear like this. It'll look clear like this when it's printed, but once you cure it and it sits out for a while, it's going to get cloudy. There's a blue, another blue one. So they make some really cool stuff. You can mix resins together. So there are flexible resins where you can mix in a little bit of flexible resin with a regular resin to make something that's, a little more durable, a little, not totally flexible. You can make some flexible ones that are rubbery. But you can mix them together. You can mix colors together. They all are basically just resin that cures at 405 nanometers, and they can all kind of be mixed together. They don't have, that I've ever seen, the additives like carbon fiber and things like that, because that's not going to cure. You know, it's just going to be a chunk of something that might get embedded in your model, and it might not. So I haven't seen anything like that really, but they do have additives that make them tougher and more flexible. There's an ABS-like one. It's not ABS, but it's similar properties to ABS. The biggest thing with these is that when you're printing them, they are kind of noxious to smell. They're certainly caustic to touch for most all of them. Let's see how much the water curable ones are. Being water curable doesn't mean that it's not caustic though. It's just, I keep saying curable, water washable. So they're in the same price range. So there are some that you can at least wash with water. You don't have to deal with the alcohol, but it's not the alcohol part that is the problem. It's really the resin itself is caustic. So you do have to certainly wear, you know, some kind of gloves to keep it off of your skin. You might even want a respirator. I don't like running these anywhere other than I've got a little shop off to the side over here that's kind of just, I can close it completely and put the resin printers in there, or put any like ABS printers or stuff like that, put them over there. All of those that kind of create a noxious odor, keep them locked away. I don't think you would want a resin printer right beside your desk like we have it right now, or in your bedroom or something like that, because they just have a little too much, even with the little filters in the back like I've got on that one. They're just still a little too noxious to be around the resin smell for very long. The other part of them is that it does work better in a warmer environment. So the resin, as it heats up, is more fluid, you know, versus being really thick if it's cold. So if you're anywhere that it's cold, then you need some way to heat up your resin. They are starting to make little vat heaters that basically you can strap around the vat down here, and this little electric heater to heat up the resin. Down here, it usually does not matter because it's probably going to be hot enough that your resin is not going to be a problem. But resin does work better when they're heated versus in any kind of colder environment. So I would be prepared, if I were going to start resin printing, I'd be prepared to get some kind of silicone surface to keep your messy stuff on. I would definitely, I know you can do it without it, but I would definitely get a wash and cure station because it makes it so much better in the end on cleaning up and just kind of containing the mess. Definitely get a lot of gloves and paper towels and trash cans that you can just, this is just a trash bag that you can throw away. That uncured resin, if you leave it anywhere, it will cure, or well, it won't cure. That's the problem. Unless it's exposed to UV light, it stays liquid and it will smear onto everything. Get you a little UV flashlight so that you can cure drips and things like that. You know, you may or may not want these little Anycubic back in the back, the little thing back there. Those little filters do help a little bit. I actually have a larger filter, like an air filter that's like the fan size in that room in there to kind of help with any kind of fumes. But also take your time with it so that you are not rushing anything around. Always think ahead of, all right, where am I going to set this thing? Like if you take this tray off of here, where am I going to set that? Because it's going to be coated with uncured resin. So you got to have a plan on where things are going to go before you start, like you're in the middle of it and you're holding a bunch of drippy resin parts. And you need to know where everything's going to go. So just be careful with the process. If you're a messy person, resin printing is probably not for you. You need to be a meticulous kind of person to get the best results from it. Just because it's so messy. I think that's probably a good intro. If y'all want more, there's not a lot more intro type stuff to do. I can show off like prints or, you know, things that you might want to do with printing. But I know most of you don't have resin printers, so I typically only do like the 1 day on resin printing just to show you that it's doable. There are consumer level stuff in the same, maybe a little bit more, but in the same price range as your FDM printers. There are just things you have to be aware of on the messiness side of this. If there's more questions about it, I'll be glad to show off more things or answer more things, but that's probably all the resin printing will actually do. There might be one more thing that we'll do later on when we get into some of the design optimization type things that makes a little more sense on resin printing than it does on FDM printing. But other than that, that's probably gives you enough information to know if you want to get into it or not. It's certainly not required for the class at all. You can do everything. Actually, I don't even know if I have an assignment for resin printers on the class. But if you do want to, if you have a resin printer and you want to do one of your assignments, the optional assignments as a resin print, that's fine. Just let me know and I'll add that as one of the options. But it's not anything required at all. It's just an information type thing. All right. Next week, what are we doing next week? Let's see, or what's the plan? We're kind of off from what I've got written down here a little bit. Joining and finishing, we might do that. We might skip that. We've kind of talked about that already a little bit. And I probably could throw that topic in with some other stuff. It looks like we're getting into some of the wireless printing. These are really cool. The problem with them right now is that the main piece of hardware that you use to do Octoprint and Clipper and stuff like that is a Raspberry Pi. You can get around it, but the main way to do it is a Raspberry Pi, and they're really hard to get right now. So I'm not sure if it makes a whole lot of sense to talk about these knowing that unless you already have a Raspberry Pi, you're probably not going to get one at a reasonable price right now. So we might go into these. I like these topics. This generative design and topology optimization, in topology scanning. We might do some of these things next week. I'll have to see what I want to do. I kind of want to push Octoprint and Clipper until later just because maybe that supply will improve in the next couple of months. The last time I checked, though, if you went to order a Raspberry Pi, the places that would even say that you could place a pre-order, it was like delivering in January or February of next year. So I did get I don't know where I put it. Oh, here. I haven't tried it yet, but you can get these. This is a Pi 400. So inside here are the guts of a Pi 4. This is actually a computer. It's like a whole little computer. It does have a different layout than what you would expect in the US, but it's a Raspberry Pi 4 inside a computer format, and they're not crazy expensive right now. And I haven't tried to see how easy it would be to make this thing run Octoprint and Clipper. So I might try that, and if it works, then at least that would be a way you could do it that's not crazy expensive. But the whole point of the Raspberry Pis originally was that they were super cheap single board computer type things, which they aren't right now. So we'll see. Anyway, we'll be back Monday, probably doing some topology optimization, which is another cool thing on how do you create geometry that takes advantage of some of the things you can do with 3D printing. All right, I'll see y'all Monday.